Today's target at the end of 42 minutes, I can graph log functions and answer questions about them. So right now, pause the video and take a moment to complete the do now. So hopefully you got these two questions right. Let's recall the first one. It says if the function g of x equals ab to the x represents an exponential growth, which statement about g of x is false? Keyword here. So we know a is our initial value, so it must be greater than 0. And b, since it's growth, must be greater than 1, so this is true. The y-intercept is always that initial value. The asymptote is y equals 0, but the x-intercept, this is false because there is no x-intercept. Unless there was some kind of shift, a vertical shift, there is not. Therefore, there's no x-intercept. And here find the inverse. So first step, switch x and y. And we know the inverse of an exponential function is a log function. So let's explore the inverse relationship between logs and exponentials. So given below is the table and graph of the function y equals 2 to the x. And so here's our graph of y equals 2 to the x. Here's our table of values. So identify the following information for f of x equals 2 to the x. Pause the video and fill this information out. So hopefully you recall most of this information, but even just observing the graph of y equals 2 to the x, the domain we could see going all the way to the left goes to negative infinity, and all the way keeps going to the right to positive infinity. The range, we observe that this only goes as low as getting really, really close to the x-axis. So it's close to 0, but doesn't include 0, so it's parentheses. But it continues to grow all the way up to positive infinity. The y-intercept is 0, 1 right here, and the asymptote has a horizontal asymptote at y equals 0. So to the left, it levels off to look like a horizontal line. Now, create a table of values below for the inverse of y equals 2 to the x, and plot this graph on the axes given. Remember, all you need to do is switch your x and y values. So for example, over here we have x is negative 3 and f of x is 1 over 8, so we'll switch. This will be 1 over 8 and this will be negative 3. Continue to fill out this table and then plot your points to see what the inverse looks like. Okay, so now we have just graphed the inverse for y equals 2 to the x. Again, if you notice, we know graphically it's an inverse because it is a reflection over the line y equals x. And so if we look at part C, refer back to the do now, what is the equation for the inverse? Well, we know the equation is, from the do now, we see that this is y equals log base 2 of x. Remember, when we convert from exponential to the inverse of log, notice in my exponential function, 2 is the base and x is the exponent. And this is y, f of x. So we just switch it. 2 is our base, x is our answer, y is our exponent. So here now, let's identify the following information for the inverse. So let's look at the domain here. Look at the domain. If you look at this graphically, it looks like it's going straight down here. Looks like it's never going to touch 0. So the furthest left it goes is from 0, but then all the way to the right, it goes to infinity. Range, my y value is up and down. It goes all the way down, and it slowly keeps going all the way up. So here we have negative infinity to positive infinity. X-intercept looks like it crosses the x-intercept right here. When x is 1, y is 0. And an asymptote. Now this line looks like it keeps going down, but instead of a horizontal line, it looks like we have this vertical line of x equals 0. Let's compare the information to the exponential function. Remember, with inverse functions, we switch x and y, but look what else we switch. Notice the domain and the range. Well, for the inverse, it's just switched. Here we have the y-intercept is 0, 1. Notice there's no y-intercept for the log function, but we have an x-intercept of 1, 0. Again, those values are just switched. For our exponential function, we have an asymptote, a horizontal asymptote of y equals 0. But for our log, the inverse, we have a vertical asymptote of x equals 0. So, once again, fill in this information so that we can have a side-by-side comparison of exponential graphs and logarithm graphs. Pause the video to fill in this information now while you're looking at this graph. So looking at this graph, we get another visual of our function y equals 2 to the x and our inverse function y equals log base 2 to the x. And we can have our side-by-side view of all this information. How the domain and range are just switched. How our exponential graph has a horizontal asymptote and the log has a vertical asymptote. Notice the exponential graph is in quadrants 1 and 2 versus the log graph, which is in quadrants 1 and 4. There's no x-intercept for the exponential graph, but there is an x-intercept of 1, 0 for the log, y-intercept 0, 1 for the exponential graph, no y-intercept for the log. So this is for our most basic function if there's no shifts. Obviously, this information changes if we go up, down, right, or left. Logarithms with base 10 are called common logarithms. When the base is not indicated, base 10 is implied. So that just means if you just see log of x, we understand the base to be 10. It equals log base 10 of x. And that's because our number system, we use the decimal number system. It's all on base 10. So for example, if we wanted to rewrite log of 1000 equals 3 in exponential form, well, here we don't see a base, so I know the base is 10. My exponent is 3, and that equals 1000. And that should make sense because we know 10 to the third power equals 1000. Logarithms with base e are called natural logarithms. Natural logarithms are denoted by ln, the n for natural. So whenever we see ln of x, we understand that to equal log with base e of x. So for example, if we wanted to rewrite ln of x equals 3 in exponential form, well, if I see an ln and I do not see a base, I know my base is e. Raised to the third equals x. Any other base must be written. If I had base 2, it would have to be written. If I had base 5, it would have to be written. If I don't write a base, then I know it's log base 10. And if I see ln, I know that it's e. Example 2. Given below is the table of values and the graph of the function f of x equals e to the x. So part A, sketch the inverse on the same axes as f of x. Here are your values, switch them, and sketch it. Pause the video now to do so. So hopefully your graph looks something like mine. Now it says to find the equation of f inverse of x. Well, if this is f of x equals e to the x, we can switch and write that as x equals e to the y. And then we know that if my base is e, then that would be ln. I don't have to write the base e, but ln of x equals y, or f inverse 1 of x. So there's my equation. Now let's graph some transformations. So let's look at example 3. Consider the parent function f of x equals log base 2 of x. Describe the transformation that has occurred to the parent function f of x in order to obtain the new function g of x equals log base 2 of x minus 4. So first let's notice what kind of transformation is taking place. This minus 4 is on the inside of the parentheses, so we have an inside change. This is an inside change. Therefore, we know that this graph is going to the right by 4. So what is the equation of the new asymptote? Well, we knew the asymptote for log base 2 of x was x equals 0. But now if we're going to the right by 4, well, 0 plus 4, we should have x equals 4. Then it says to identify the coordinates of the x-intercept 1, 0 after the transformation has occurred. Well, if log base 2 of x is 1, 0, and we're going to the right by 4, 1 plus 4 is 5, 0. Now let's sketch this and check it on your calculator. So pause the video to check it on your calculator and then sketch it. Okay, so hopefully your graph looks something like mine. And now let's identify the domain and the range. So if we look at the domain here, well, now since I have my vertical asymptote at x equals 4, I know my graph will never touch 4, but it goes all the way to the right. So my domain is from 4 to infinity, not included. But notice my range hasn't changed because this is still going all the way down and it's still growing slowly up. So my range stays the same, negative infinity to positive infinity. Example 4. The graph of y equals log base 2 of x is translated to the right 1 unit and down 1 unit. The coordinates of the x-intercept of the translated graph are, well, if it's going right 1 unit, that means that the x-intercept would be going to the right. And then it's going down 1 unit, so the whole graph is being shifted downward. So remember, going to the right, that would be considered an inside change. An inside change is always opposite. So to the right would be x minus 1 for going to the right by 1 unit. And then down 1 unit is an outside change minus 1. So now you can plug this into your calculator and you'll see that the coordinate of the x-intercept is choice 4. Now let's look at this regions question. It says graph y equals log base 2 of x plus 3 minus 5 on the set of axes below. Use an appropriate scale to include both intercepts. So you can go ahead and plug this directly into y equals. Remember, we need to include both intercepts. So when you look at your table of values, make sure you're looking for points where x is 0 and where y is 0. Pause the video to come up with your table of values. Okay, so hopefully your graph looks something like this. Remember, it said to include both intercepts. So notice I have included my y-intercept of 0, negative 3.4, and my x-intercept as 29, 0. Then be sure to just include a few points before and in between. Okay. Describe the behavior of the given function as x approaches -3. Well, you see your graph starts to go down, and if you look in your calculator, you'll see there's an error. Again, that's because this is shifting to the left by 3, my inside change. So we know log base 2 of x has a vertical asymptote at x equals 0. Here my vertical asymptote is x equals -3. So the behavior is our function goes close to -3 but never touches it. So as x approaches -3, we know the function f of x is actually going down to -infinity. And it says now to describe the behavior of the graph as x approaches +infinity. Well, as x goes to the right, as x goes to +infinity, we notice that f of x grows ever so slowly also to +infinity. Example 6, graph f of x equals log base 2 of x plus 6 on set of axes below. So notice here you have an inside change. Plug this into your calculator, come up with the table of values, and then plot the points on the graph. Do this problem on your own. Be sure to check with me to see that it's correct. Make sure you're answering these questions, A, B, C, D, and E. And when you're finished and everything looks good, you'll then take your exit quiz.